Units are really, really important. And one of the errors that students make frequently is they don't write down the unit. They just write down the numbers because you get focused on the numbers. The number without its unit is meaningless. Like this sentence. When my son was 7, he walked 3, and when he was 4, he could throw his baseball 8 and tell us that his school was 5 away. Does that make much sense? No. Or you go to McDonald's and you say, I'll have 5. Well, do you want 5 coffees? Do you want 5 sodas? Do you want a number 5 meal? They don't know what you want. You can't just have the number. You need a unit. So it's really important. Units make all the difference. I think this is when my son was 7 months old, he walked 3 steps. And when he was 4 years old, he could throw his baseball 8 feet and tell us that his school was 5 blocks away. That makes more sense. You got to stick the units in there. There's 2 common unit systems, the English system and the metric system. If you grew up in this country, you're more familiar with the English system. That's feet and pounds and miles and things like that. We don't use those units in science. They will show up in this class only in making you convert from English to metric. We need to get comfortable with the metric system. It's based on powers of 10. Once you get used to it, it's beautiful. It's so much simpler. So, another example of units mattering. 1999, NASA lost a $94 million orbiter because 2 groups of engineers failed to communicate to each other the units they used in their calculations. Basically an inches versus centimeters problem. So it was built to orbit too close, and it descended into the Martian atmosphere and burned up. Over units, $94 million. Don't be that person. The SI system of units, the international system, is based on the metric system. As far as I'm concerned, the difference is irrelevant. I will use the terms interchangeably, so we're just not going to worry about it. I'm not going to test you on what is the basic unit of each of these. That's where things differ, what's considered the basic unit. I don't care about that. I care about, do we know how to use the system? We need to have a basic idea of how large these units are because we're not necessarily familiar with them. If you have a clue about how big a unit is, then you can have an idea whether your result makes sense or not. If you calculated someone's height and it was 7 meters, would that be reasonable? Well, 7 feet, yeah, they're really tall, but there are people who are 7 feet tall. But a meter is very close to a yard. Nobody is 7 yards tall. That'd be 21 feet. Not happening. Okay? Not going to quiz you on how these things are defined. It's interesting, but you can read about that. A meter is similar to a yard. Kilogram is about 2 pounds. There's a picture of the official kilogram. So a kilogram, about 2 pounds. We don't use kilograms much in chemistry because that's awfully big for when we do experiments. So we use the gram a lot. A nickel has a mass of about 5 grams. So a nickel is 5 cents. It weighs about 5 grams. It's a small unit. Grams and kilograms measure mass, which is slightly different than weight. Weight is actually the force of attraction by gravity, and mass measures the quantity of matter. So if you weigh 100 pounds on Earth and you travel to the moon, where the gravitational field is 1/6 that of on Earth, your weight is less. You're less attracted to the center of the moon than you are to the center of the Earth. You'll weigh 1/6 of 100. 100 divided by 6. I have a calculator right here. Like 16 pounds. Does that mean you suddenly are emaciated and lost most of your body mass? No. Your matter is the same. Your mass is the same. So as long as you stay on the planet, weight and mass are about the same. 1,000 grams or 10 to the third grams is equal to 1 kilogram. We'll talk about metric prefixes in a minute. Time, it's based on seconds. So that's nice because that's the same as the English system. Prefix multipliers. We need units of different sizes because we measure things that are different in length. If I wanted to measure the length, how long is the longest side of this piece of paper, what would I use in the English system? Probably inches, right? I could do it in feet. Would it make sense to do it in miles, though? No, that'd be pretty ridiculous. We want to use a unit that is similar in size to what we're measuring. So an inch, will give me 11 inches for this piece of paper. That's a reasonable number. I don't want super small numbers. I don't want super big numbers. So we have units that are different sizes. In the English system, they are related by seemingly crazy numbers. Okay, there's 12 inches in a foot. There's 3 feet in a yard. There's 5,280 feet in a mile. Who made that up, right? And I can't even remember how many yards are in a mile. That one just escapes me. I think I don't know. Anyway, 2,000 something maybe. No, it's 18 something. Anyway, it's hard to remember. In the metric system, everything is powers of 10. There's a set of prefixes. They mean what power of 10 do you multiply that unit by? Does it get bigger? Does it get smaller? The same set of prefixes is used for everything. So you learn one set of prefixes and you can do all the conversions. So once you learn the prefixes, it's much, much better. So if we want to know the relationship between a kilometer and a meter, kilo is a prefix. The abbreviation is lowercase k. Kilo means 10 to the third. So 1 kilometer is 10 to the third meters. So that looks like, how would I do that on my calculator? Well, that's the same as 1 times 10 to the third. That is scientific notation. By the way, in scientific notation, on your calculator, that would be 1. And then you should have a button that says EE, or it might say EXP. And then you put in the exponent 3. That button you need to get familiar with. We're going to use it a lot. That button stands for times 10 to the. So 1 times 10 to the 3. You do not press times 10 and then the EE button. So we'll practice that more in lab as well. 1 kilometer is 1 times 10 to the third meter. Centi stands for 10 to the minus 2. So if I have 1 centigram, and I want to know how many grams that is, instead of writing the C, the abbreviation, I write what it means. C is like a nickname for 10 to the minus 2. So 1 centigram is 1 times 10 to the minus 2 grams. There are other ways to make these relationships, and if you're good at that, awesome. If you're not, follow this pattern. It works every time. What happens is that students forget which unit is bigger, and so they've got 1 millimeter, and they tell me that that's 10 to the. They tell me that that's 1,000 meters. That's like telling me that an inch is 12 feet. You recognize that as ridiculous because you know how big an inch is and how big a foot is. Millimeters and meters, that might not click with you. Well, this is wrong. Milli is 10 to the minus 3. So 1 millimeter is 10 to the minus 3 meters. The prefix goes on one side and the 10 to the something on the other side. And we're going to be practicing that because we're going to have to do these sorts of conversions a lot as well. Here are the prefixes. You should memorize these. This column is nice, but there's way too many zeros in there. So I do not think that's useful at all. So just ignore that. these are the ones you should memorize. 10 to the what? Most of them are multiples of 3, 12, 9, 6, 3. We've got some exceptions here, the 1 and the 2, 3, 6, 9, 12, 15. Here are the names and the symbols. We have to be very careful. We have capitals and lowercase letters. The difference is important. Capital M is mega, that means a million. Lowercase m is milli, that means 1/1000th, 10 to the minus third. Those are really, really different. The other prefix that starts with an M is micro. We ran out of English letter M's, and so we use the Greek M, mu. In general, if it's a capital, it makes it larger. And if it's a lowercase, it makes it smaller. Kilo is kind of an exception to that, though. You should memorize these. There's going to be a bunch of things you need to memorize. You should get a pack of index cards and make some flashcards. Carry them with you. You may think you don't have any time. I don't have any time either. I could tell you about what happened this weekend. It was crazy. And yet, I managed to knit. And I knit socks, and I can knit a pair of socks in about 2 weeks. And it's not because I sit at home and knit socks. It's because I carry them with me everywhere. If I'm riding in the car, if I'm at the kids' baseball game, I'm waiting. If there's a long train, I'll pull them out and start knitting. There are little bits of time where you can't do much. You know, you can't go out and plant a garden. But if you're waiting for a train, you can pull the flashcards out of your pocket and flip through a few. So make use of those lost minutes by carrying flashcards with you and memorize these things. So which is the most convenient unit to express the dimensions of a polio virus, which is about 2.8 times 10 to the minus 8 meters in diameter? And it's giving us these choices. Well, we need to know what those prefixes stand for. So mega is 10 to the 6. So that's 10 to the 6 meters. Milli is 10 to the minus 3. So 10 to the minus 3 meters. Micro is 10 to the minus 6 meters. And nano is 10 to the minus 9 meters. So if you're picking a unit for this, you want the power of 10 to be close to this. So which one of these is closest to 10 to the minus 8? 10 to the minus 9, right? So nanometer would be a good unit. In nanometers, this would be 28 nanometers. So that's a nice number, right? We wouldn't want to use megameters where we'd end up with, 2.8 times 10 to the probably minus 14 or so. That would be a bad choice. Questions? So the point of metric prefixes is to make the units a convenient size. Derived units. Volume. Most volume units are derived. You think back to geometry, measuring a cube and finding its volume, length times width times height. Each of those dimensions is measured in a unit of length, but when you multiply them, you get a volume. And the volume would be in cubic meters, or cubic centimeters, or cubic millimeters. Or you could have anything else. So those are derived. Liters and milliliters are also units of volume. They are not derived, though. So we need to have a clue about the size of a liter. A liter is similar in size to a quart, but what makes more sense to most people is you know how big 2 liters is, right? 2-liter bottle of soda. And a milliliter is a milliliter bigger or smaller? Smaller. Milli means 10 to the minus 3. So there's 1,000 milliliters in a liter. 1 liter is 10 to the minus 3, or 1/1000th of a liter.